Thank you so much for being part of KodeCamp AI 2025. We are really excited to have you guys. So today we are going to be doing something technical. All right, so I need to share my entire screen today because we'll be doing some in-depth work. So we'll be working on image processing, the OpenCV, and I think I hope we are all with our laptops and we're ready to start then run some image manipulation. Having said that, um, first of all, I need us to open to download PyCharm. PyCharm download. So go to your browser, download PyCharm ID. So I'll give you guys like probably 10 minutes to do that. PyCharm, just go here, download, right? Download the ID. That's it. It's 1.2 gig. Nigeria economy. Okay, I think we need to use VS for this thing. So you go to your browser, download VS Code. You can either download Windows, Windows laptop, Linux, or Mac. By the way, how many of us here doesn't have this ID is installed on your laptop? PyCharm or VS Code? Can I see you raise your hand? Okay. Carl Winnie. Who else? Please, if you don't have this installed, if you don't have VS Code or PyCharm, can I see your hand up? So I know I'll just handle it individually. Right now, can't see anyone's hand. Okay, so just download VS Code, right? Download VS Code and go to python.org and download Python. You can download the latest version, but I would always like if people download a version that is a little bit back. Now that's so that you can get a more stable version. So what you would do is you come here and then you search for downloads, click here, or release. Then you download maybe Python. I would love to go with 3.30 or 3.12. So you download 3.12. And this is better. So download Python. Hold on. Gonna get a version of it that is. Okay, this one 3.12.7. So I'll just share you guys this on this much. I'll share it on the chat. Okay, if you have 3.11, it's still okay. Wait, how many of you guys here don't have Python installed? How many of you don't have Python installed yet? Okay, you guys all do. All right, so I can just assume. So can I move on? Is there anyone that is having issues? Anyone that doesn't have Python installed or PyCharm installed? Is there anyone here? Please, if there's anyone that doesn't have PyCharm or Python installed, can you like raise up your hand or signify? Hello. All right. So I assume everyone is good. Okay. So in your PyCharm, wait, you guys all have PyCharm installed? I think you guys are, can you guys hear me? Hello.
Yes, we can hear you. We can hear you.
Okay, I'd like you guys to write which ID you have installed. If you have PyCharm, write it here. If you have VS Code, you write it here on the chat. Which ID do you have installed here? So I know which one I'm using to teach. Okay, one VS Code. VS Code. Okay, do you have Python installed already? You have Python installed already? Okay. So I love using PyCharm though because PyCharm is a little bit easier to run, but I'll just use VS Code instead. So VS. So what you do is you come here, you create a new window with profile. We need to create a new project, right? So you just come create a new window with profile. New profile. Then you can open. You choose any folder you want. For me, I'm going to create a new folder called it KodeCamp. Right. Okay. And the next thing we're going to do is to create a virtual environment. Create a virtual environment. All you need to do just to type this. Now actually create an environment here directly. With this. All right. That should create it for you. Just click here, create environment. If you can't create it from there, you just come to your terminal. Come to your terminal, and then you type Python 3/m venv venv. That will create the environment venv. You guys done it? Yo, you guys done it?
Yes, it's done.
Okay. So is there anyone that is lost? Like I don't think everyone is actually on track. Don't think everyone is on track with it, but I just assume everyone is on track with it. So to activate your virtual environment, just do source VENV, that's the name of the virtual environment. Bin dash activate. That should activate it for you. So um tell me when you guys are ready. So I can move on. We have a lot to cover. We have just a few minutes to go. Are you guys good?
Hmm?
Are you guys good? Can I move on?
Hmm?
Why you not smile?
No, I did meeting now.
Okay.
You can move on, sir. You can move on.
Yes, I didn't. Oh,
Which meeting is this?
doctor.
Hello, can I move on? All right. Okay. So I haven't done this. The next thing is to install OpenCV. So we'll come back to our slide. So today we are going to be working on image processing with OpenCV. All right.
Yeah, I'm sorry, sir.
Yeah,
What am I going to type? If I want to create the environment.
Okay, to create the environment, click the type all right. Okay. You type this, Python 3 VENV. Have you done it? Have you done it? Hello?
Yes, I'm typing it.
Okay, that should create a virtual environment. Yes. We are spending 23 minutes in virtual environment. Okay, and then to activate it, you type. Okay, let me create a notebook here. First of all, create virtual environments, and then you activate virtual environment. Virtual environment. Okay, so now to install PyCharm, to install OpenCV, we need to understand what OpenCV is. So OpenCV is the open source library for image processing. All right, with over 2,500 optimized algorithms. And these algorithms include a lot of things like edge detection algorithms, blurring algorithms, like simple things that you are meant to do by yourself using mathematics. Simple things like contour detection, like these are things that you use pure math to solve. So OpenCV by itself automatically does all these things. It does it just like give you a system, a platform where you don't need to do most of these things, because if you want to do these things yourself, you need to use NumPy, hard code Python, and some heavy heavy mathematics computation. And OpenCV already did. All right. And enables tasks like first detection, object detection, action classification, camera motion, 3D reconstruction, stitching, like a lot of things you can do with it, just as it is. So, um, so before we get into writing anything, we need to understand how images works. So today's slide covers everything we are to do for today and next week Monday. So if we don't finish it, we'll continue on Monday. Sorry, on Tuesday. All right. So how does images works? Images, everything starts from a little processor, a little microcomputer, a little transistor on your computer, which signifies off and on some black and white dots, some RGB lights, right? So it all starts with binary, and then from binary we have like we combine it together to get a code. From that we combine it together to get a color, and so forth and so forth. So digital image is a grid of dots of picture elements of red, blue, and green elements, which we call pixels, right? So this pixel is a single dot in a digital image and the smallest portion of block of the digital image. So if you look at this image right here, don't know if I can't see, but if you look at this image, you'll see that there is red, there's green, and there's blue. So as we combine these things together, that's what forms an image. So if you look at this place where there's a P, you will see that we still have the red, green, and blue. But now we reduce contrast, we reduce brightness. Once we reduce the brightness, once we manage control the brightness of the image, of the pixels, that's how we form a particular image, and that's how we form a particular character. So in this sample, we see that we reduce the brightness of the red, blue, green in some pattern, and we were able to form P. This is exactly all image around the world, even the image of yourself that you have. This is how it works. There's no two ways, there's no mapping. This is exactly how everything works. Now this thing boils down to what? From simple numbers to some simple arrays to some simple metrics to some simple dots and to some simple binaries. There's no magic. So if you look at this image of this guy's, this human face right here, you see that we have RGB dots which came together to form the eye. But look at this, for example, this part of the eye, the red, green, blue, they are literally dark. And that's why it's able to form this part. This side that is white, the red, green, blue, is a little bit lighter. With this, we can form anything that we want and any type of thing that we want. This is simply how images works. So a pixel picture element is a single dot in an image. Image is the smallest in an image and the smallest portion of it. All right. So resolution of an image is often measured in dots per inch or pixel per inch. Higher resolution of an image looks better. What this means is that an image with more resolution has more pixels, right? And it looks better. So you can zoom into an image to see individual pixels. Do whatever they want to do. So where in AI, in deep learning, do we need to process images so we can get good results or we can do whatever thing? Or what steps do we take? Right? But one step we take is always to load the image, pre-process the image, like resize the image, normalize the image, augment the image. Then we do feature extraction. Feature extraction involves like extracting the important part of the image that you need. All right. And then splitting the paper into like trend, validation sets, and test sets, turning the model evaluation. These are things that you're gonna like do in I think in your third week or your fourth week. I'm just bringing it up right now. So like tell you guys about it and you know like what you're going to see. So, and also evaluating on validation set, hyperparameter tuning, test set evaluation, and post pre-processing. So simple processing thing, common processing, which is always done in image, all right, and which we are going to cover. So before we get to the step of like training model, evaluating model, we normally and most times use to process the image. That's where OpenCV comes in, or you can use some other libraries. But OpenCV is the best known one that does the job mostly well, right? So common pre-processing steps are always resizing image. So if the image is too big, let's say we have an image of size 200 by 200, and this is typical for an AI model because an AI model, we need like to pass some data set, which is good, but also like a little bit reduce its size so we can get a lighter model, right? So most times we often need to reduce the image size. And there are times where you need to also put image that have bigger size, like bigger quality, so you can get good results. That's what leads to resizing, also cropping image, normalization. Normalization has to do with like normalizing an image, maybe normalizing the brightness, contrast, or making an image better. Augmentation has to do with rotating an image. So let's say I'm training a cat. Hey, Chineke Meo. Let's pray for grace today. Because if you guys don't understand, you rest your hand, raise it above your head. So if I'm training a cat, the cat is looking like this. If I'm training a cat, the cat is looking like this. To an AI model. The AI models understand that this is a cat, but it gets to a point where when I want to test the AI model, I test it with an image of a cat rather looking like this. Now, if the AI model wasn't properly trained, it would predict this not to be a cat. Because obviously it doesn't look like what it was given. Even if you as a human being identify it, AIs are not human. So what do you do in this case? You augment the image. Augmentation now has to do with this taking one image and performing like 10 different or 5 different operations on this image. That one image literally produces 5 or 10 different images. Number one, rotating the image. We have this image, we rotate it upside down. We can rotate it like to 4 different angles. Right, left, up, down. That's already 4 images for us. 2, increasing the brightness. That's 5 images. 5, reducing the brightness. That's 6 images. 6, reducing the hue or the contrast. That's like 6 images already that you produce out of one. 7, cropping the image, giving us just the leg or giving us just the from the head up. So with this, we'll be able to augment the image and produce like 10 different images from one image. With this, we've increased the amount of our data set. If we train our AI with this image, our AI will be able to know the image of a cat no matter how you give it in future. That's what augmentation is. That's what augmentation means. Grayscale conversion. Grayscale means like converting image from RGB, the normal image that we have, like this CodeCamp, to black and white. Histogram, equalization, Gaussian blur, noise reduction. All these things is part of processing. Gaussian blur is just blurring the image. The noise reduction is reducing noise, right? Okay. Edge detection. Edge detection has to do with like detecting edge of images. Like detecting. This is something that we'll cover next week, but today is the beginning of our pre-processing topic. So edge detection in image. This is a good example of edge detection. So if you look at this image, we pass it an image like this, and then we are able to detect the edge of the image. You see. So all these things are very, very needed. It depends on the application you're building. Some application would need this, some application wouldn't need this. All right. Okay. And then color space conversion, converting from RGB to hue, saturation, volume to lap, contrast adjustment, thresholding, binary variant, morphological orbs, centering, SHV adjustment, hue, saturation, volume adjustment, and the rest of it. We are going to handle all of this little by little, but we wouldn't be able to finish them today. All right. So, what's the first thing we do? The first thing we're going to do now is to install OpenCV. So we just install OpenCV Python. OpenCV/Python. The command is here. If you're using Colab, you need to start with something like this. Install OpenCV. All right, that should be able to install OpenCV for you. So me, don't have OpenCV, I need to install it. Have you guys installed it? Not find version that satisfies requirement. OpenCV Python. Oh, sorry. Are you guys with me? Can you guys hear me? Are you guys seeing my screen, please?
Yes, we can see it.
Okay, is anyone lost? Is anyone lost? Is anyone lost? Okay, I assume no one is lost. Have you guys all installed OpenCV? If you guys all installed it, is anyone having issues? Can I move on?
Someone is having issue in the comment section. Someone is having issue in the comment section. Can you please check that out, please?
Yeah. Yeah. I think I should move. The temp pip is not recognized. Hey. Wait, are you using a Windows laptop? Who is this? Can
Yeah,
you
yes,
unmute?
yeah.
Did you install Python?
Yes, I have Python on the system.
You need to add Python to your path.
Okay. I think
Yeah.
I will let me do so.
Okay, just do that. Then you cut me and I'll correct you. Okay, so that's very easy, right? Now the next thing we need to do is create a simple script. So our job starts now. Our job starts. Print. Hello. It is that my code is running very, very well. Okay, good. So the first thing we are going to do is to load an image. So how do you read image? How do you read image in OpenCV? Very, very simple. So for me, I'm going to go online. I'm going to grab one. Power. That's the way it is. Okay. So to open an image in OpenCV is very easy. The only thing to do is, first of all, you need to import CB to this way. Import CB2. All right. Now, once you import CB2, all you do is call your image. Also, CB2. Then you put the part of the image. For me, my image is called image.png. And then I'll try to do something very, very mad right here. Print this. And then we need to see what it gives to us. Run. We compare my code again. My code is not running. What's going on? Hold on. Where's the problem? Python mesh. Okay, my code is running. So instead of doing that, I'll just do CV2. Let's insert. I'll give the name image, then image, then do CV2 dot okay. So this should pop our image for us if we got it right. Where is the image? I'm looking for it. One CV2. All right. Okay. So if you look from the slide, this is not what is on the slide. On the slide right here, which I share with you guys. The slide shows how to open images using PyPlots. All right. So I'm going to explain that to you, but I needed to explain to you guys firstly how to open it. CB2 himself. So first thing you do is you just come, you read your image, right? And then you show your image with this. Now, while your image is showing, we need the image to hold on and wait for some time, right? And that's what we do here. Then after we're done processing, we destroy all windows with this. So once I close this, or once I stop my application, I should close all the windows. It's as simple as this. And this is also meant to come with more like a keystroke. Maybe if I press X, the image should go and the rest of the thing. All right, so um I was testing my code to make sure everything is running well. So let's go back to our slide. Okay, so what do we do? First thing we need to do is to do what? Is to define our image show function. And this is what we are going to use the matplotlib to do what? To show our image. And then we choose the size of the image. That's going to be 8 pixel by 8, 8 pixel. And then with matplotlib, you need to set the image color, right? And we are going to use BGR to RGB. All right. Now, why? Because OpenCV works with blue, green, red images. So we need to convert it to RGB. So piplots will show it now, right? And then we show the image. So it's a very simple thing. So you just farm here, and then we define our function. What's the name? CVEng. One more thing, sorry. You need to install pip install maths. Um, pip install matplotlib. So you need to have matplotlib installed, right? But you can choose to use either ways. You can choose to use matplotlib, or you can choose to use OpenCV. But I just need to show you the two ways. After this, I'll proceed to using OpenCV instead to avoid like so much stress. Okay, are you guys with me? Hello, can you guys see the screen?
Yes, yes, you're seeing it, you're seeing it.
Okay. Okay, I'll proceed. I think what we'll do is you just take screenshot of the things and then I'll just move on with it. So we are going to pass in the image, right, that we are using. And then we need to import map.lib, right? So import maths.lib.py plot as plt. Then the first thing we need to do is to declare the size of our image. So to do that, we set our figure size equals to 8 by 8. And then we just do plt.imshow, then save it to color. We need to pass in our image and then save it to those. Color BGR to RG. All right. And then plt.show. I'll just do this instead. And then with this, I'm going to show my email. So CV.
There's no translation.
All right. So I'm trying to run to test it. Actually, you guys are all running your script. Okay. As no attribute CV color delay problem. To be capital R. Clear. Yes. Um, are you guys with me?
Yes, we are with you.
Okay. Hmm. Okay, I'm trying to figure out why the image is not showing for me. So maybe something I'm not doing well. One minute. Need to check if it is actually seeing the image. If IMG equals print. Yes, what's going on here?
The image is showing up on my side here, but when it shows, it will just exit straight. I don't know why.
Even me, I don't know what the problem is. Oh wait. Oh shit. I didn't put a bracket after this. Sorry.
Show.
I needed to put
Okay.
there's meant to be a bracket,
Okay.
Yeah. Man, that's so stressful. Instead of just doing cb2.im show,
It has opened
then
here.
yeah. So I don't know which one you guys would choose to use, but that was just too stressful though. All right. Okay. So that's how simple it is to show an image in OpenCV. All right. Let me go back to my slide. Are you guys with me? Hello.
Yes, we are here. We are here.
Okay. So I'm going to convert an image to one thing black and white and also to grayscale. So OpenCV has a default function where you can use to convert an image to grayscale. So to do that, all you just do is just to come here, right? So I'm gonna bring this down. We'll be using it down here. Grayscale is equals to cv2 dot cvt color, and then the first thing you do is to pass your image, and then you pass the color you want to convert it to. OpenCV has like a lot of colors you can play around, like a lot of things you can do, a lot of image transformation. So if you look at this, what you check, you see cv2.color, right? Then we are saying we are converting from BGR to what? To gray. We're converting the image from BGR to a gray image. And then all we do is just to come here and then we show the grayscale. And that should show us our image in grayscale. So we've done the first transformation, which is converting an image from a normal pixel of image to a grayscale image. And also we can also convert to black and white, all right, from our grayscale. So what we do, we first of all pass in our threshold. So it needs two parameters, which is threshold, and then image. So I'm going to call this image BW. That's going to be equal to CV2 dot threshold grayscale 1 to 8. Now this 1 to 8 is we are passing parameters, so we're going to adjust these parameters and see how it behaves. All right. Um. One sec, 1 to 8 and 2 5. And then what are we converting it to? We're converting it to CV2 dot trash binary. And this should show us, this is what we need, right? This should show us that image. So this is one of the most simplest way you can use to convert an image to black and white. First of all, you need to convert the image to grayscale. All right. And then you pass that grayscale to this to OpenCV building function, which is going to help us to convert the image to black and white. But I'd like to print this so we see what it is. It's actually the threshold, right? So let me close this and run this again. So we should see, sorry, I should be on top here. All right. So our threshold is what? 1.28. That's what we gave to it. And then this one is just the max value. So I can reduce this to 400 and then let's see what happens. Okay. It's not as white as it was before. I'll just use 200. And, uh, okay. So you can just go out, you can just go and play around with them. You can just go and play around with them and check out and things you can just do with them. You can pick any image. Let me see, I have an image of someone. I have an image of a guy. Then I want to convert it to, you know, anything. I want to play around with it. Um, I have this image, for example, image of this guy. So I can just image copy. See? So you can now these things are needed in CNN in when you're building your AI model because there are some things you need to build and you can't like pass like a very good example is when you're building an AI model for brain tumor detection, MIR scan. These scans comes in terms of they come like um um they come in most of them come in RGB images. So let me show you guys. Most of these scans come in RGB images. So you see, then I need to apply some things to make these images sharp, to make them blurless, to really make them black and white, to so I can play around with them. I can choose to like pick this one right now. Um, let's say for example this one. I'll copy this image. And then I can choose to play with this. Copy. Then we see difference. Okay. And then we can adjust these. You can pretty much do anything you want. Let me see if I can make this one. Yeah. So these are all. Can you see? So with this, the part of the image that I want to show very very well is coming up, and with this, it will make our AI to be able to train well and understand things well and give you better results. So far we've handled two things: blurring and sorry. Okay, so you see, this is a little bit looking a little bit better, good. Yeah, but these are the things that makes your AI model work very, very well. But it depends on the application, it depends on the things you are building, it depends on whatever thing that you're building. All right. Um, let's go back to our slide. Okay. So we've done this, converted the black and white to grayscale, video capture. So how do you capture video in OpenCV? This was actually one of the most simplest, though. This one is actually very, very simple. So I'm just going to show you guys how videos are captured in OpenCV. The first thing is we need a video for test. So I'm going to get a very, very simple image of me. Uh, any simple test image.
No. 10 minutes. 10 minutes.
All right. Okay. So I'll just create a different called vid.py. Okay. So how do we display image in OpenCV? I'll import my CV too, right? And then I'll call my image, my video, because of CV2 dot video capture, passing the name of the image, which is called water. I'll copy this. As the name of the video. And then the next thing I'm gonna do is to pass in is to write a while loop that will be showing us the video. Now, why are we doing this? Why are we showing it on a while loop? Image is a loop of video is a loop of images. So when you see any video, it is just images looping in speed, looping like 50 frames per second. 50 frames per second means 50 images in 1 second. So it means in 1 second you have seen 50 images or 60 frames per second, which means like you've seen one image 60 times in 1 second. Like in 1 second you've seen this video of me like moving one, two. With that, we combine all those together and then we can form a video to the point you won't even be able to capture it. So what do? We set this rate. This rate is just a value that tells if is a true value that tells if our image is actually showing or if it is empty or something. And then the frame is going to be the frame that we're talking about right now. And this is what we are going to be showing. So all we do is just we get our video.read, and then if rate. Now that's if true. Because I told you guys this is a value that tells us if the image is actually if it is true, if it is a video, if the video is there. But it's a boolean value, so I'm gonna print this so you guys see. I'll print this to if rate, and then save it to dot im show. And now what are we showing? We are going to show these frames, and that's what you're going to be seeing with the image show frame. And else, that's if there's no image, if it is false that there's actually there's no video, then we break. It's as simple as that. Outside the while loop, what we do is just video dot capture release. So what this happens is that once we are done running the image, once we are done running the video, and then we end it, it should release the capture, and then the normal thing I showed you guys before to destroy all windows. These are simple as A, B, C, D, E, F, G. All right. So I'll tell you with Python v.py. Okay. There's a little, let me pay this so I see. What is it saying? Im show frame opposite in function overload resolution for missing required argument. Oh yeah, that's true. So if I'm using cpt.image show and not like the first one we wrote here, all right, this is one we wrote previously. I'm not using this. I want to use the normal cpt library. You need to pass in the title of the frame. Like I'm gonna call the frame video. Im show this is gonna be a title of the frame. Then I'll show my video. So these are simple as okay. What's the problem? Im show math is not non-PRA, not that scalar. Wait one sec. Let me check where the problem is. Okay, let me check what is causing this. Hmm. Okay, right. Video the read during this CVT dot insure. Okay, let me try something. If CV2 dot wait. The same thing I forgot. CV2 dot wait. Wait. Hmm. So what we are doing basically is I'm setting a key that I used to close the video. All right. So once I press this key, the video should close. Okay, I think there's a bigger problem here. Let me check what the issue. Show is back. Let me show video. Oh no. Why am I not seeing well? I'm meant to pass frame, not video. Oh Anyways, okay. So the issue there was I was literally passing the wrong thing. I meant to pass the frames and not the video actually. So because this is what I want to display, I want to display this. But what I did right here is to tell OpenCV that once you should like here, like come here to the video and press Q to stop the video. One more thing you can do is also you can pass in videos directly from your webcam. So I can decide to pass in the webcam volume. Most computers, the webcam volume is always zero. Just come here. Okay, mine is me to allow, right? Then with that, OpenCV will allow you to pass in videos from your webcam. So you're gonna open up my webcam, you should see me. So I'm actually in a workspace by 10 p.m. teaching you guys. And this is me. Hi. All right. Okay. So it's actually 11 p.m. So I think we should end it here for today. You've seen me for now. All right. Do you guys have any questions before I call it a day? Um, but I'll prefer if you have questions, you rather ask in the Discord channel, I'll answer because we are not done with the class yet, and I'd like us to finish it up on Friday. And also, I'll drop your tax today at night. Okay, maybe one person can ask a question. Let me close this. I've been talking to myself all this time.
No, no, no.
Sorry, can I speak? Been raising my hand.
Yes, you can.
Good evening. So I'm actually sharing on the chat that I don't know, mine is not showing. I'm trying to follow up with what you're doing, but then the first one you did, the image, I can't see anything coming up at all. I don't know if there is something I should do.
Okay, let me see your screen. Can I see your screen?
Yeah, I'll share. Okay. I think the screen is, it says I can't share.
Um, one sec. Can you hear me?
Yes, I can.
Um, um, I carry in the call. I don't know how to allow participants to share screen. What's your name? Mboro. Mboro. Mboro, I can't see you on the chat. Okay. I need to make you an host. Put in waiting room. Okay. I'm gonna send you a screenshot of what I'm gonna send a screenshot to Discord channel instead. You use that because uh,
Okay.
Mboro.
Okay, I'm Janet. You can just call me Janet. Sorry, that one is not showing on my screen.
Okay, I made you a co-host. Can you check if you can share your screen?
Yes, I think it's up now. Okay.
Okay.
So this is where I have it.
I can't see your screen now.
It's not up. I'm
Mm.
sharing.
No, I cannot see. Is it on the video or on the image? Which one?
On the, what is it called? On the ID.
No, are you having issues with the image part of things or the video?
Yes,
Sorry.
I'm actually on that image. I've not done anything. It's just that image and it has not shown. I can't proceed like from there.
Okay, can you send your screenshot to the Discord channel and also to the WhatsApp community? I'll help you from there. Are you on the both of them?
I'm on only Discord. I can share with them.
Okay, I'll share you the code right now. I'll share you the code. Okay, I'm sharing the code to the community.
Okay.
All right, it's on the channel. Okay. Um, that is it for today. I'll drop some tasks on the LMS. I don't know how to assign tasks, but iKis is gonna work me around it. I'll drop some tasks and before Friday, you guys should get your tasks. Also, please, if you don't have Python, VS Code, like these things installed, get it ready because on Friday we have to do a lot of things and we'll be spending at least up to 3 hours on the call. So, alright,
So, sorry, on Friday or Tuesday. I think we're having class on Tuesday.
it's Tuesday. Oh, today is already Friday.
Yes.
Alright, on Tuesday. Um, see you guys. Bye. Please, if you have questions, you can either drop on the
Wait,
Discord or on
This,
the WhatsApp community.
PM,
Yeah.
Like this, drop your slide, please. So I can
My
read
what?
that. Your sliding, your sliding.
My what?
He said
Oh, your
slide.
slide.
Um. Okay. Let me drop a link to the slide. I can't find
Thank
it.
you.
I need to make it shareable.
Sorry, please. The code is shared on Discord chat. That first line after the import matplot, there is
Uh,
nothing. There is no image again. You are not assigning again. Like,
the image I send it down. So it's a
oh,
function we
okay.
wrote, so you can use it later on.
Oh, okay. Okay.
Yes. Okay, I've shared this slide on the Discord. All right. See you guys on Tuesday.
Okay.